Okay, so this lecture is now about basically the reverse of the chain rule. All right. So if we have a look at it, this is I've given you a function here, and remember when we're dealing with the function, we find the derivative of the bracket. So we would jump this down, and then we write it down, and then we write down its derivative. Okay, so its derivative would sit next to it, all right? So if we're trying to go with the reverse of the chain rule, ideally we would like the derivative next to it, okay? So if we have the derivative next to it, then we can simply go the reverse of that, and we can just integrate the bracket, okay? So it's exactly the opposite. So what we do is, now this is basically, if you look at this function over here is a power function, all right, but it's not linear, all right? So this whole section now is on the fact that what if it's not linear, all right? So if it's not linear, we need to look for the derivative, right? And the derivative next to it is what we're going to, so there's my power function, so this is my derivative. So the derivative is what we're going to call the dude, just for, so that a nice little way to remember it, okay? The dude is my derivative, okay? Now, if I can find the dude, right? So in other words, if I have a power function and my derivative, my dude is next to it, all right? Then what I can do is absolutely ignore the dude and just integrate the bracket. So here, the dude, ignore, and all I do is add 1 to the power and divide by it, and there it is, plus c, okay? So if we have a look then at the chain rule when it comes to trig, the same sort of thing applies, all right? So this is now a power function, okay? So I've got sine 2x cubed, all right, or cubed. So if I had to find the derivative of this now, it would have been, the chain rule would have been find the derivative, so it would be 3 sine 2x squared, which I've got here, times by the derivative inside, times by the derivative of that angle. Okay, so actually what would we like to be able to work backwards is we would like to have the derivative of the angle, derivative of that, the dude, and the derivative of the angle next to it, so that we can ignore this part and work backwards. Okay, so if we have this and we have the cos 2x times by 2, that would be considered my dude, which means I could ignore the dude and just simply integrate the bracket, which would be add 1. 3 divided by 3 gives me 1. So I've got sine 2x all cubed plus c. Okay, so what I'm looking for is the dude. Remember, the trig dude, though, is cos of the angle times by the derivative of that, which we can even call the little mini dude. Okay, so let's look at some examples. All right, if we have a look at this one, we've got 2x squared minus 1 to the power of 4. I can see that it's not linear, so what am I looking for? First prize would be to get the dude next to it, all right? It is, there it is, the derivative of that is 4x, so that is the dude. So what do? I ignore the dude and integrate the bracket. So this should be, in our heads now, 1/5 2x squared minus 1 to the power of 5 plus c. Okay, if we look at this one, we look for our power function. This is my power function. It is not linear, so I am looking for the dude next to it. The dude is 3x squared plus 4x, so that is the dude. So I ignore the dude and I integrate the bracket. So that's going to be 1/4 x cubed plus 2x squared to the power of 4. I don't have to do any integrating inside it. This is prize number 1. Okay, if I have something like this, same sort of thing, I've got the power function. So my power function is sine x to the power of 4. What is my derivative? This is my sine x. The derivative of sine x is cos x. So that is the dude. So I ignore the dude and integrate the bracket. Okay, I hope that makes sense. If not, you need to go back to the others and practice that, and then come back to this and practice this. Okay, so what happens if the dude isn't quite there, right? It is, but what you need to do is maybe potentially add a constant, times it by a constant, and so on. Let's have a look at it. So in other words, if it's almost there, all right, we need to compensate, all right? So if I took something like this, all right, the first thing I think I should do is move that 1 minus 5x cubed. I look at it and I see that it's not linear. So my goal is to see if the dude is next to it. Now the dude here would be minus 15x squared. Minus 15x squared, okay? So I go, okay, well, I'm missing a minus 15, all right? If I had a minus 15 here, then it would work, all right? So the 6, can you see, wasn't relevant, so I took it out of my integral. It's not going to disappear. It's part of my sum. So this becomes 6. I want to put that 15 in there, so I need to compensate by dividing by minus 15. All right, which part do I ignore? I ignore the dude. This minus 15 is going to stay. So that part's the dude. That's what I'm going to ignore. So what am I going to do? I'm going to write down minus 6 over 15, and then I'm going to integrate this bracket. Okay, so minus 6 over 15, 1 minus 5x cubed to the half, times by, or divided by minus a half plus a half, minus a half plus 1, which is a half, which is actually timesing by 2. Okay, so the answer should be that. Just try this in your head and you'll see that this times by 2 is actually dividing by half. Okay, so let's look at the next one, and that's cos 2x. Right, so there's that double angle there, the sine 2x there. All right, so this is a power function. So I go, okay, that, and sometimes it's helpful to write it as a power function. All right, so the cos of 2x to the power 4. Now, the derivative of cos 2x is negative sine 2x times by 2. So I'm missing, I've got the sine 2x, which is good news. So I'm missing a negative and I'm missing another 2. So that 2 is the angle. Remember, sine 2x times by 2. Have a look at the first example if you're not sure. So what I've done is I've created this part over here and this part over here, which is what my dude is. So I'm ignoring that. This part is staying, so it's minus a half times by 1/5 cos to the 5 2x plus c. Okay. All right, then we look at the next one. All right, so that's x times by e to the x squared minus 1 dx. All right, so what have I got here? X squared minus 1 dx. That is not linear, so I want the dude next to it. The derivative of this would have been 2x. So actually what am I missing is a 2. So I put a 2 in there, and I now can compensate with a half. So my answer is a half e to the x squared minus 1 plus c. Okay, I hope this makes sense. So this is practice so far. So if I was you or later, have a look and see what you would do for each of these different questions. All right. So you kind of probably want to pause the video now, try these, and then you can play it back a bit later. So to stick with the day, pause it and move on. All right. But the rest of the slideshow, which I'm going to carry on with, are the solutions to these. Okay. So let's have a look at it. So the first one is 6x. There's my power function. It's non-linear. So therefore, I want a dude. So I know I wanted 2 there. So I'm going to take the 6 out. I'm going to put a 2 in, and I'm going to compensate with a half. So because a half times 2 gives me 1. So the half is staying, and I'm ignoring the dude. So 6 over 2 is 3. And then I'm going to just integrate the bracket. So I get 3/4 x squared plus 1 all to the power 4 plus c. I hope that makes sense. This one over here is cos x to the power of 3. The derivative of cos is negative. Derivative sign is cos, so the integral of cos is sine. So actually my derivative is next to it. So it's going, derivative of sine is cos. The integral of cos is sine. All right, so there shouldn't be a negative over there. So the answer should be a quarter cos to the 4x plus c. This is not good. Okay, so it's a quarter, but just integrate the bracket, no issues. Number 3 is a power function over there. So basically what I could do is, if I rearrange this, I'm going to get x to the minus a half, and then x to the half plus 1 to the 4. So this is my power function. And if this is my power function, my dude is a half x to the minus a half. So actually I've got an x to the minus a half, and I'm missing a half. So if I put my half in, I can compensate with a 2, and I ignore the dude and integrate the brackets. So that's going to be 2 over 5 root x plus 1 to the 5 plus c. Okay. This one over here is a power function. So I have a look at my table, actually I don't even have a look at my table. I've got cosec to the 4x. So that can be sine to the negative 4, right? Because I've got a cos, and if I look at the table, I'm not going to get anything here. But cosec and sine are maths, because 1 over sine is cosec, and 1 over cosec is sine. So that's sine x to the negative 4. Now, if I look at that, the derivative of sine, sorry, this is right. So the derivative of sine is cos, so I'm happy with that. Okay, so the derivative of sine is cos, so I don't have to do any changes. So what do? I go and I integrate that, and I get 1 over minus 3 sine to the minus 3x plus c. Okay, so that the derivative is next to it here. The derivative needed to be minus sine, sorry, and so I need to compensate with that negative. Okay, let's have a look at this one. This one, straight away I look at and I realize, oh, hang on, that's linear. So this is now easy. I'm going to go 1 over 5 times by, and I have to add 1 to this. So 1 over 5 times 7 over 4. 5x plus 3 to the 7 over 4. That I'm going to just simplify, and I get 4 over 35, and it's an easy enough finish. This one over here is just simply another one that I can go by inspection. So I'm going to go 1 over 5, and the integral of cos is sine. So it's cos 1 over 5 sine 5x plus c. Look out for the linear ones. They're very, very easy. Right, number 7 is looking at it. It looks like it's another dude. So it's not linear. So it's x squared minus 4. So that's 2x. And the dude is next to it. So what do I need to do? Nothing. All right, the dude's there. So I just want to integrate the bracket. So that's a half plus 1. So that's divided by 3 over 2, which is the same as times by 2 over 3. And that's why I've got this solution. Okay, let's look at number 8. E to the x times by e to the x plus 4e to the power of 3. Again, this is my power function. It's not linear inside, but I do have the derivative of e to the x plus 4e. Remember, 4e is just a number. So the derivative of e to the x is e to the x. So that is my dude, which means I can absolutely ignore it, and I integrate the bracket. So this should be a quarter e to the x plus 4e to the power of 4 plus c. All right, this one over here is looking very much like a dude. I want to bring that up. So I've got 1 plus 3 sine x to the minus a half dx. Inside here, what is my derivative? So the derivative of 3 sine x is 3 cos x. And the derivative of 1 is 0. So that should be 3 cos x, which means I'm looking for a 3. I compensate by putting in a third, and I ignore the dude. So I ignore this, and I go, okay, minus a half plus 1 gives me a half. So I'm timesing by 2 over 1. So that's 2 over 3, 1 plus sine x to the half plus c. All right, and then the last one, e to the 2x over e to the 3 is simply e to the 2x minus 3. This is linear, so therefore I can just go 1 over 2 e to the 2x minus 3 plus c. Okay.